Okay, so we're going to share the screen. All right, so now our goal is to deploy the XGBoost model to GitHub using ONNX runtime. So we're going to go back to our Jupyter notebook. So you can see that here, our Jupyter notebook. And we're going to now run the XGBoost part, right? Because we need to train the data, build a model, and then deploy it. So that's what we're going to do. Okay, so what we need to do is, as I said, I asked you not to stop the Jupyter notebook so we don't have to reload everything, and we can just continue from this point. So we are going to okay. So we are going to run and load our xgb.xgb regressor into our variable regressor. Okay. So we can just hit run. So that instantiates basically our XGBoost. Then we're going to fit it on the train, on X-tray Y train. We're just doing everything. Then we're going to predict with it, just so that we can measure performance. And I get an R square of 0.39, but the champ of today, Ravathi, right, achieves 78% R squared. All right, so you can achieve pretty good results with your XGBoost model, right? Now, the XGBoost model is in regressor, the variable name regressor. So that's the variable that we are going to deploy. Okay, so now that's basically training the XGBoost. So let's, just like we've done before, now let's just add the portion of exporting it. So I'm going to say here, deploy XGBoost model. Okay, run. All right. So this is all new code. We already have all the libraries that we need. We're going to define, so for ONNX runtime, we have a few things that are a little bit different. We have to define a variable called initial types. Okay, so that's the first thing. So initial underscore types. Okay, so that's the list with basically a tuple. Okay. And then the tuple wants to know what the size of the tensor will be and then the type. Okay, so the type is going to be float input, or the name. This is the name actually. So the name is float underscore input. Okay, just like that. That's going to be the name. And then we define here the type and size. So it's going to be a float tensor type. And then we specify the dimensions with square brackets. And it's going to be none, comma, 11. And what that means is none basically can be 1, 7, whatever it is. So it could take multiple inputs at once of vectors that are of size 11. The 11 obviously is pretty important here because it tells it the features, right? Everyone with me? So that's it as far as that part. So let's just hit run. Okay. And then now we just export it, right? So we're going to create ONNX model equal ONNX ML tools dot convert underscore XGBoost. XGBoost. Our XGBoost model is in the variable regressor, right? So that's the one that we plug in here. And then we just provide initial types. So we're going to say initial underscore types equal initial underscore types. Make sense? So we've basically now converted our regressor into ONNX, and now we're just gonna save it. So then we're gonna say ONNX ML tools dot utils dot save model. Okay. And then the model that we want to save, of course, is ONNX model. Just like that. And then the last thing we need to specify is what the name of the file itself will be. So you can call it something like XGBoost underscore wine quality underscore ORT for ONNX runtime, but I'm still calling it .ONNX. Got it? And that's it, guys. That's pretty much it. Now, as an exercise, I'm not going to make this homework, but as an exercise just for fun, you guys can try random forest from sklearn and try to deploy it. And it should be a similar approach, okay? All right, so that's basically it. So, we can go ahead and hit run. The file should now exist. So if we go here, you can see it. It's right there, ready to be deployed to GitHub. And that's our ONNX model. Okay, so it'll be the JavaScript for ONNX runtime is a little bit different. So I'll show you that, although consistent, a little bit different. So remember, we're using two frameworks. For PyTorch, I only use ONNX. For XGBoost, I'm using ONNX runtime. ONNX runtime is the latest, as far as I know. And there could be a newer one already. All right, but because this moves really fast, but anyway. Okay, so let's go back to the Jupyter. Now, one fun thing about ONNX runtime is that you can use ONNX runtime on the Jupyters as well. So like we've created the model and we can use it in here. So to do that, I'm going to create a session. I'm going to invoke RT, which is runtime. We did this in the imports at the top of this Jupyter. And now I'm going to say RT inference session. And I'm just going to plug in the name of the file, which is XGBoost. So now I'm no longer using the model and regressor, but instead I'm reading it from the ONNX file back into XGBoost. Back into the Jupyter Notebook. So I'm doing XGBoost underscore wine quality underscore ORT dot ONNX. Okay. So hit run. And there you go. Now you have session has read from the file the model. So why do we want to do this? I mean, you might want to do this, but it's useful to get certain parameters or values in the ONNX file. So for instance, let's say I want the names, right? So I want the input name, the output name, which we've seen it's useful to have those. So I'm going to do input name session dot get inputs. So that's a function, and then from it, it's going to be the first 0 and then dot name. So if I hit this one, oh, and I have to print it obviously, so I'm going to input name. What was input name? Float input, remember? We specified it here, float input, in the input types. Got it? We can do the same for output name. So let's do, let's say label name. Gonna be session dot get outputs function, grab the first value, and then dot name. Label name. So it's called variable actually by default because we didn't name this one. So it's good to know once we have the output that its name is variable. Got it? Make sense? Yeah? All right, great. So now what we want to do is we want to deploy this model to the web. So it should be the exact same process. So we're done with the Jupyter, right? The file exists. Now I'm going to go back to GitHub. You guys have a repo, section 1. I'm going to create a new folder for XGBoost, okay? So how do we do that? You go to add file, create new file, XGBoost, right? readme.md, and then you can add a comment deploying XGBoost models with ONNX runtime. Got it? So go ahead and hit commit. And there you go. So now we've got this folder. And what we want to do now is we want to do the same thing, right? We're going to add to our XGBoost. So we go to add file, upload files, choose your files here, find the section for this class, which is this one. Go to data. And then our model should be in here. No? Oh, here it is. XGBoost wine quality ORT.ONNX. So then hit commit changes. Now we go back to deploy to production, section 1, wine quality, XGBoost. And there's your file. The exact same thing we did before, but for ONNX runtime. Yes, sir.
Yeah, mine's 27 megs.
27 for this ONNX one?
For the XGBoost one, yes. Because, yeah.
It's big, you're saying. Mine is 45.2 KB. How is that possible?
27.5 megabytes? Oh, yeah.
That can't be. How about the rest of you? Huh? KB or MB? KB, yeah. Go here to the. So go here to the Jupyter notebook and find the file. Okay, let's go back to here. So this is all we did, right? After you do the regressor, right? You do this. Did you say float input? Yeah, float input, float tensor type.
Correct. I don't know what.
You exported the regressor.
Correct.
You exported this variable regressor.
Mine was named different, but yes.
Okay. Do you have this set up here in XGBoost?
Mine has more stuff in there.
That might be it then.
So I just use my.
You use more estimators. So, okay, so that's probably the explanation. You have a bigger regression tree.
Yes.
So what you're gonna have to do is, for now,
Take it down to 100.
do this. So what does that mean? It means that your model will not be as accurate probably as you had it before, but I can't do anything about that because it's GitHub. It's what I was saying. The thing that's limiting you here is GitHub. GitHub only allows you to load a model up to 20 or any file up to 25 megabytes. So obviously, if you have a really accurate tree, it might mean that it's a big tree and it might be bigger than 25 MB. So that's the issue. Does that make sense, guys? Any questions on that? So for the sake of just completing this exercise, go with a smaller one. Mine was achieving mine achieved 40 R squared, okay? So you're gonna have to play with this and maybe just try smaller ones, but that are still good somehow.
I changed my estimators down to 1,000. They brought it down to 8 megs.
Okay, there you go.
Down to 474. It's not-
There you go. Nice job, Sean. I like what you did. You found a balance between what the resources limit you and then, finding a good model. That's kind of how sometimes what you have to do in machine learning. It's work within your means and build and still achieve a good model. 74. Still though, you're second place.
Yeah.
All right, great job. So you saw what Sean did. Nice job. All right, so now we have a few minutes. Let's try to wrap this one up so we don't carry this forward to the next class. I'm just gonna create the two files just like before and copy the code from the GitHub. You guys can just reference that. So I'm gonna go to index and then just explain it, right? So I'm gonna go to the GitHub here. With the previous section, I already did this, so I'm gonna copy its wine quality for them. XGBoost. We've already loaded the file. We will need to add the link, of course. And then we do index. So I'm just going to copy the whole thing. Control copy. So now I'm going to go to your section, XGBoost, and I'm going to create the file, okay? So I'm going to do add file, create new file, index, oops, lowercase, no, just hit cancel here. So new file, index.html and paste the code. All right, so hit commit changes, and now we've got the file. So let's just read through it. Couple of things to highlight. Here for ONNX runtime, notice that we use a different distribution. We use ort.min.js instead of what we use for just regular ONNX. Okay, so that's different. This is the same line. This is our JavaScript that we're going to add from our index.js file. This is just our basic CSS. and the 3 sections as we had them before. So as you can see, the boxes div, right, it's got X1 to X11, and then the names box 1 to box 11. Then we've got our button, and that is on click run example, just like before. So you can look at the previous video. And then finally, we were going to display the values in the same div predictions. So pretty much nothing changes in this index from our previous example, except that this here is now for ONNX runtime instead. Questions? All right. Now we're going to do the JavaScript part. So we can refresh this. Okay, there's our file. Now let's copy. So I'm going to go to, for the previous section, wine quality, XGBoost. And I'm just going to, because we don't only have 8 minutes left, I'm going to copy index.js. The code is consistent, but a little bit different. So I copy it. And now I go to your section, XGBoost, and I'm going to add a new file. So in this case, create new file, index.js, and I'm going to paste in the code, and then I'm just going to explain it. This one is a little bit different. So commit changes, and that's it. So if everything is correct, in 10 minutes, our website should work, right? So that's the other thing. Let's just copy the URL so we don't have to worry about typing it. So we can just copy this. We've already done pages, so that should work. So we can go to this section, XGBoost, and let's just paste in the link. And we're going to change the path a little bit. So the path would be, instead of just wine quality, it is section 1, wine quality and XGBoost, just like that. Got it? All right, so commit changes. So the last thing we need to cover is, so let's go. This is your XGBoost deployment. The file is XGBoost underscore wine quality underscore ort.onnx, right? So we want to make sure that's correct. So I'm going to click on index.js, and it is the same file. Notice the code is very similar. I did do this, but I don't think this is necessary actually. So you can just comment it out because this one would replace it anyway, okay? And it worked for the previous example. Then we've got the same thing we did before with the 11 text boxes. We read them in with get element by ID, right? And then we have X. Now, this is where it changes a little bit from ONNX. Notice that here we invoke ORT instead of ONNX, but it's similar. We do ORT.tensor float32 X, which is this one, and then 1,11, the size of the vector. That creates tensor X. Then we have a thing called feeds, which is what's going to hold our input. So if you notice, the name is float input. Remember, if we go to the Jupyter Notebook, the name is float input. We just did this. So you can see you specify here float input, and then you assign to it tensor X, which is this, what holds the data from the text boxes. Got it? Then after that, it's similar. We do ORT inference session create, and we read in the ONNX file into session. So now it's loaded. And now finally, we just do session.run. This holds the model. And that, what do we provide to it? Feeds, which contains the input. So it's changed a little bit, but it's the main things. This gives us result. And then from result, we just do .variable.data, assign it to output data. And then here I just parse float and fix the decimal points. And that's it. After that, output data gets assigned to predictions. So we do get element by ID predictions. And then the same thing, enter HTML, a table, and our output data goes there. And that should be it. Got it? Any questions on how to deploy XGBoost to GitHub with ONNX runtime? All right, so hopefully that made sense. The code is on GitHub. I'll post these videos, of course. Obviously, I would want to see this run. It's been 12 minutes. No, it's been 3 minutes, right? Yeah, go ahead. It works? Okay, perfect. Thanks, Lucas. All right, so I'm going to click on it. Let's see, maybe it'll run. Nope, hates me. Oh, no, there it is. It does not hate me. And it's more accurate, right? It's 550 here. So at least it's towards the average. So go ahead and play with these values, change them up. Let's do 1, 1, and hopefully it'll change. Yep, 4.16. All right, guys, so that we made it with 3 minutes to spare. So I'll stop the recording here, but that concludes. So hopefully now you know how to deploy PyTorch models, at least for regression, and also XGBoost models to the internet, and they run via GitHub. In the future, if we do classification, the only difference might be that we would need to learn how to load an image into the website, convert it into a tensor, and it's going to tell us if there's a cat, dog, or something. Got it? All right, great. Great job. So great job on the, I'll stop this.